Hi students, today you are going to look at the topic probability, and our subtopic is multiplication law of independent events. By the end of the lesson, a student will be able to 1. Understand the concept of multiplication law of independent events. 2. Use the multiplication law of independent events to solve problems. Now let's start with our main topic for today's lesson, that is multiplication law of probability or multiplication law of independent event. Now before I'll continue, I want you to pause and try to understand the word independent. When you say independent, in your own explanation, what comes to your mind? I hope you get it. Now let me bring in these two examples so that you understand the word independent as related to probability. Now, when you say Ghana is an independent country, it means that Ghana as a country does not or do not depend on any outside world country. Are you getting it? It means Ghana is on its own. So whatever that you do as Ghanaians or as a country do not affect any outside world country. Okay? The same thing applies to them. If they also do anything in their country, it doesn't affect us. Okay? Now let's look at the second scenario. Assuming I have given you a die and a coin for you to throw the two at the same time. You could notice that for the coin, you can only see the head or the tail, and also on the die, any of these numbers can come up. That is, 1 can come, 2, 3, 4, 5, and 6. Any of these numbers can come. Now, so assuming 1 pop up on the die, it doesn't mean that it is the coin which has caused that. Also, if on the coin you see the head, it doesn't mean that it is the die which has caused that. Okay? So I want you to understand that throwing the two objects, their outcomes do not affect each other. Okay? Hence, you can say that the two events occurring at the same time are independent. I hope you now have an idea about independent event. Very good. Now, based on this, let's try to get more understanding. Two events, X and Y, are said to be independent if the probability of the occurrence of X does not affect the probability of the occurrence of Y, and vice versa. I hope you get it. So what you are trying to say here is that if X and Y are independent events, then it means that the probability of the occurrence of X does not affect the probability of the occurrence of Y. Okay, the vice versa here means that the probability of the occurrence of Y also does not affect the probability of the occurrence of X. I hope that is clear there. Okay. Now, for two independent events, X and Y, the probability of event X and Y happening or occurring together is given by the formula probability of X and Y is equal to probability of X intersection Y equal to probability of X times probability of Y. So make sure that you put this formula in your head, okay? So try to remember this formula all the time. So in simple terms, if you are saying that two events are independent, okay, then the probability of the two events occurring together or at the same time is given by probability of the first event times the probability of the second event, okay, and vice versa. In multiplication law of probability, the word and or the symbol and means multiplication. I hope it's clear. Now that you know the concept of the multiplication law of probability, let us try to use this concept to solve problems. So that's worked examples. Question 1. If M and N are two independent events such that probability of M is equal to 3/7 and probability of N is equal to 14/15. Find probability of M intersection N. Okay, now let's look at the solution to this question. Now from the question, we were given probability of m to be equal to 3/7 and probability of n is equal to 14/15. Since in the question m and n are independent, okay, then it means probability of m intersection n will be equal to probability of m times probability of n, okay. Now you know that probability of m is given as 3/7 times probability of n, which is also given as 14/15. Now when you simplify these two probabilities, you end up getting 2/5. I hope it is clear. Now let's look at our second example. Question 2 goes with this. A and B are two independent events such that probability of A is equal to 3/7 and probability of A intersection B is equal to 2/5. Find I, probability of B, II, probability of A union B. Now let's look at the solution to this problem. Now in the question, we were given probability of A equal to 3/7 and probability of A intersection B is equal to 2/5. You can recall that since A and B are two independent events, then it means that probability of A intersection B will be equal to probability of A times probability of B. Okay, as usual, you know that intersection means multiplication, as learned earlier on. Now you are asked to find the probability of B. Okay, so let's represent probability of B to be what? X. Okay, now 2/5 represent the probability of A intersection B equal to probability of A, which is equal to 3/7 times probability of B times probability of B, which has been represented by the variable x. Okay, now I want to simplify this. You know, 3/7 times x will give us 3x/7. Do you get it? Now when you simplify this, we are going to get 3x/7. That is 3 times x will give us 3x, okay, over what? 7, because the x here is over 1. So the 1 will also multiply the 1 here, and that will give us 3x over 7. Now, this is simple linear equation. Now, when you get to this place, you can do two things here. You can find the LCM of the denominators and use it to multiply each of the term, okay? Or you can do what you call cross multiplication, okay? So by cross multiplication, 7 times 2 will give us what? 14. Then 3x times 5 will also give us 15x. So as you can see on the screen, so 5 times 3x will give us 15x, equal to 7 times 2. That will give us what? 14. So now you have to divide both sides of the equation by 15. And when you do so, you end up getting 14 over 15. Now let's look at II. You have to find the probability of A union B. Now I want you to pause here and ask yourself, what's the probability of A union B? I hope you can now recall that probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Probability of A is equal to 3 over 7 plus probability of B equal to 14 over 15. That has been calculated in I, minus probability of A intersection B equal to 2 over 5. Now when you simplify this, you end up getting 101 over 105. I hope you've gotten this one too. Let's look at our third question. Given that x and y are independent events and that probability of x is equal to 0.5, probability of y equal to m, and probability of x union y equal to 0.8. Find the value of m. This is a very interesting question. Now let's look at the solution to this. In the question we were given, probability of x equal to 0.5, which is the same as 1 over 2, probability of y equal to m, and probability of x union y equal to 0.8, which is also the same as 4 over 5. Now, from the addition law of probability. You know that probability of X union Y is equal to probability of X plus probability of Y minus probability of X intersection Y. So when you look at the question critically, you see you don't know the probability of Y. You also don't know probability of X intersection Y. But you know that probability of X intersection Y can also be expressed as probability of X times probability of Y. So when you do substitution here, probability of X union Y is equal to 4/5. Probability of X equal to 1/2 plus probability of Y, which is given as M, minus, then you do expansion here, probability of X times probability of Y, of which you know already. You know that probability of X intersection Y can be expressed as probability of X times probability of Y. So in our next step, you are also going to do substitution because the probability of X was given as half, that's 1/2, and the probability of Y is also M. Okay, now you know, now this is a simple linear equation. So what we are going to do here is to find the LCM and use it to multiply each of the term. Now our LCM is going to be 10. So as you can see on your screen, you multiply each of the term by 10. Okay, so 4/5 times 10 equal to half times 10 plus M times 10 minus half M times 10. And when you simplify this, you are going to get 8 equal to 5 plus 10M minus 5M. Okay, grouping like terms, you will get 8 minus 5, and I hope you know why here is negative. The 5 was positive, so moving it to the left becomes negative, equal to 10 minus 5M. So when you simplify, you get 3 equal to 5M. So in order to get M, you have to divide both sides by 5, as you can see on your screen. So when you do so, you therefore have, so when you do so, you will get M equal to 3/5. And I hope this explanation is also clear. Now let's look at our last question. Question number 4. A coin is tossed twice and a die rolled once. Find the probability of the following events. A. 2 heads and a 5. B. Exactly 1 head and an even number. Solution to the problem. Let X be equal to total outcomes of throwing a coin twice. Therefore, the sample space for throwing a coin twice is going to be head, 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 tail, tail, head, and tail, tail. Now, when you count the number of elements in set S, you are going to get 4, as you can see on your screen. Also, let U be equal to sample space of a die. Now, you all know that when a die is rolled or is tossed, the possible outcomes are 1, 2, 3, 4, 5, and 6. And when you count the number of elements in set U, you are going to get 6. Therefore, the number of U is equal to 6. I hope it's clear there. Now let's move on to the main question. A. Now you have to find the probability of 2 heads and a 5. So when you look at the question, it's talking about 2 events here. Getting 2 heads and getting a number 5. Okay, so the word and is in between the 2 events, indicating that they are independent events. Okay, so let X be equal to event of getting 2 heads. Now you know from the sample space, when you throw a coin twice, you can only get head, head. Okay, and it appears once in the set. Therefore, the number of X is equal to 1. When you find the probability, you end up getting 1 out of 4. Okay, because the total number of elements in set S is equal to 4. Again, let Y be equal to the event of getting a 5, and 5 can be found in set U once. Okay, when you count the number of 5 in that set, is only what? 1. So therefore, number of Y is equal to 1. So when you find the probability, you are going to get 1 out of 6. So now probability of 2 heads and a 5 is equal to probability of X and Y, which is equal to probability of X intersection Y. You all know that AND is the same as intersection, which means multiplication. Therefore, probability of X intersection Y is equal to probability of X times probability of Y. And when you do the substitution, you are going to get 1 over 4 times 1 over 6, whereby 1 over 4 represents the probability of X and 1 over 6 represents probability of y. When you simplify, you get 1 over 24. Now let's look at the B part. Let t equal to event of getting exactly 1 head. Now when you look at the set S at the top there, the event of getting exactly 1 head, you can only see head, tail, and tail head. And when you count the number, you are going to get 2. Let K be equal to event of getting an even number. So from set U, the even numbers are 2, 4, 6. And when you count them, you are going to get 3. Therefore, the number of K is equal to 3. Therefore, probability of 1 head and an even number is going to be probability of T and Q equal to probability of T iteration Q. Therefore, probability of Q iteration T is equal to probability of T times probability of Q, which is equal to 2 over 4 times 3 over 6. And this will give us 6 over 24. And when you simplify, you get 1 over 4. I hope this one is also clear. Until you meet again, I say bye-bye.